So here we have our curved surface. I'm going to go through this quite quickly. If we want to look at what is the pressure that this fluid is exerting on the curved surface, the first thing we're going to do is we are going to draw orthogonal or perpendicular lines around the surface, like so. And all we want to do is we want to figure out what is the vertical component of the resultant force acting on this wall and what is the horizontal component of it. We can then use those two to actually figure out the total component. The vertical component is going to be due to two things. One is the weight of the water inside that those boundaries we drew, and the other is going to be due to the pressure distribution that is acting on this imaginary surface here. So we've got this imaginary surface up here with a pressure distribution. This is exactly like our horizontal rectangular surface. We know how to figure out what the force there is from previous video. And then the resultant force in the horizontal direction, we just have a pressure distribution acting here that is the same as our submerged vertical rectangular plate situation. And we know how to figure out both where a resultant force for that acts and what its magnitude would be. And so our vertical force here, our force in our vertical direction is going to be equal to, we'll call this our force, our F sub y plus W, and you'll call this F sub x. So our force in our horizontal direction is just going to be F sub x. And then we could figure out that our resultant force, which would be acting, say, at some location here, the magnitude of that would be equal to the square root of F sub v squared plus F sub h squared. The angle that would make with the horizontal would be related to the magnitudes of F sub v and F sub h, according to, say, this is a horizontal line, this angle here, alpha, we would say the tangent of alpha would be equal to F sub v over F sub h. And then to find the location of where that acts, this is F sub r, we would need to do a sum of moments about some point and set that equal to 0 and solve for that distance. I'm not going to go through that now. It's going to be different for each situation how to do that. But remember that you can break these curved surfaces into vertical and horizontal components, and then they just become problems like we've already gone over in the previous videos. So that covers what you need to know for hydrostatics. Watch these videos as many times as you need to be able to understand how to do it. And